What is the circumference of a circle? The length of the perimeter of a circle is from here all the way around to here. The distance around the edge of the circle from here to here. Here to there.
So how do we measure the circumference? It's a circular object. It's a little tricky. I could start here and wrap my ruler around. It's not going to work very well. I'm not going to be very exact. In this case, my circular object can be cut and very simply laid out in a straight line. Now you can see that circumference is linear. It forms a straight line that can be measured. So what if you want to know how far a bike will travel with one rotation of the wheel from here to here, all the way around one time? Well, we could use a formula, but first, let's just try guessing for fun. I'll show you how to do it, and then you can pause the video and do your own setup. You're going to need string and some chalk and maybe a tape measure and of course a bike. There's 4 steps. The first step is mark your starting point on your bicycle wheel with the string. I chose to tie my string around where the nozzle is for filling it with air so it's easier to see. Then you're going to place your bike on a straight line. You could use a seam in your driveway or a crack in your driveway if you got a straight one. I'm going to use my tape measure to draw a straight line with chalk. Then you're going to align the starting point where your string is tied on the bike down at the bottom so it's touching the ground right where you want it to start, and then you can mark your guesses with chalk how far you think it's going to go. Okay, here are my 2 guessers. Annalise, take the piece of chalk. You get to go over to the line and you're gonna guess if this wheel rotates one time all the way around. Do you see the string here? Where do you think on the line that string will touch the ground again? And I want you to mark it with a line.
I would guess right here.
Okay, mark a line there, put your letter A next to it for you. Okay, hand it to Marilyn. Where are you gonna guess, Marilyn? You wanna pick a different spot and make a guess?
What do you guess, Mom?
Okay, Marilyn's guessing pretty close to Annalise. And I think I'll put my guess, here, I'll take the chalk. Woo! I think I'll put my guess a little bit closer. Okay, now it's your turn. I'm gonna pause the video and put the 4 steps up on the screen for you, and then you can go outside or wherever and get this set up but don't turn your bicycle wheel yet. All right, now we're back and we're going to actually calculate how far the bicycle wheel will go before we turn the bicycle wheel. And we're going to do this with a formula. Circumference equals 2 times pi times r. So this pink circle here, from one point all the way around it, that represents our circumference. I'm going to use that same color here for our formula. Circumference equals, and then 2 times pi, which is the constant 3.14, times r. Now r is the radius, which is measured from the center of the circle to the edge. So I will label this with a little r for radius, stick it here in my formula. The radius is the distance from the center of the circle to the edge. But if you continue the radius all the way through the circle, it has another name. If you draw the line all the way through, it's called the diameter. But for now, I'm going to mark this with another r. This side is r, and this side is r. So we could say that this line all the way through is r plus r, or we could also say it is 2 times r. So using the commutative property of multiplication, we can rearrange our formula up here. I'm going to switch the location of some of these variables. I'm going to keep circumference equals, I'm going to switch the pi and the radius. Since I'm multiplying all these numbers, it doesn't matter what order I do it in. And then this 2 times r right here, that is this distance, also known as the diameter. Okay, so my bicycle has a diameter of 19.5 inches. Or I could say 2 times the radius all the way across is 19.5 inches. Then I'm going to multiply that by pi. I'm actually going to input the constant we used for pi in here this time, 3.14. And I'm going to use my calculator. 19.5 times 3.14 in my calculator is 61.23, and we were measuring in inches. So the circumference of my bicycle wheel should be 61.23 inches. Let's go check it out. All right, we used our formula. We came up with 61.23 inches. We had measured our diameter, or 2 times our radius, to be 19.5 inches. So, Nicholas, can you hold this right here at the start? Connor, can you go grab the piece of chalk over there? Okay. Oh. Okay. 61.23 inches is about right here. I'm going to draw a big line right there. Okay. Now, let's see how it works out. Okay. Hey, pretty good.
So it landed right on this line. I'm going to be closest to mine. So, Mom, when
bike a smaller wheel. We've marked our string already, and I will show you how to do this by just guessing and not using a calculator. You can get pretty close without a calculator. If you can visualize how large the diameter is, or 2 times the radius, it's about that big. And pi, the number 3.14, is really close to the number 3. So I'm going to take this distance and multiply it by 3. And just a little bit larger than that should be our circumference. So if I start here and I go 1, 2, 3, somewhere in here is my guess for where the circumference is. Give it a ride. We got a very flat tire. That's probably going to affect our outcome. There it is. Now it's your turn. You get to go back to your bicycle and use your formula. Bring a ruler or a tape measure, or if you don't have a tape measure, maybe you could use a string to cut the length of your diameter and then use a ruler to measure it. Insert your radius into the equation, or insert 2 times your radius, which is your diameter, and multiply that by 3.14, and whatever you get as your answer, go mark it on your line and then test it out. See if your bicycle actually travels that distance. And if it doesn't, maybe find out why not. Could you have made a mistake somewhere along the way? And then you can try this with other objects too. Any cylindrical object, anything circular in your house, and you can try to estimate where you think it will land when it's rolling based off of this formula, or by taking your diameter times approximately 3, or 3.14. Okay, we're out here at the Altwick farm. We are going to try it with the tire. We're going to estimate using our little rule that approximately 3 times the diameter plus a little further, because pi is actually a little bit bigger than 3. It's 3.14, and we'll see if we can get close. The radius is, what, 30? Almost 32 inches. I'm going to try it this way too. Yeah, we're going to say a 64-inch diameter. Okay, we're out here. We're going to mark the tire with a piece of chalk. This is where we're starting. And we're going to go 64 inches in that direction. Mark, somebody put a post right there, mark that spot. 1, okay. And then, you don't have to push it in the ground, just hold it for a second. 1, 2, okay, now mark that spot.
Right here.
That's good. And then 3, mark this spot. Sorry, I can't see that very well. Okay, so we've marked 3 lengths of 64 inches and then a little bit further. So Annalise, how about you put your 4th one just a little bit further? Let's try that. Okay, that's our guess. We'll take the first 3 out. Take the first 3 out. Yeah, that one stays in. There goes the tire. Watch the chalk line. There's halfway. A little farther. And stop. Okay, we were off by a bit.
The length of the circle. Yeah.
Say it again. From here. Say the words.
From here
To here.
to here. Here.
Do it again. From here to here.
Okay. Here from here.